Hi, my name is CJ Craig, and I'll be presenting analysis of year-over-year changes in risk factors disclosure in 10K filings by Vipula Rutt, Aparna Gupta, and Mohammed J. Zaki. The objectives of the paper are to predict bank failures using convolutional neural networks, uh, implement weighted sentiment analysis on the words and change sentences using and running a support vector machine on them, perform multiple and multivariate linear regression analysis on the performance indicators associated with banks' leverage and return on assets. Looking at the data, they extracted 10K filings in HTML format from the SEC Electronic Data Gathering and Analysis Retrieval website, EDGAR. And also in their data, they captured 730 bank holding companies. 675 of them are non-failed and 55 of them failed. As you can see, the table to the right displays this, and it shows their training and test split. And then also sentence data, where it looks at all sentences and then change sentences by looking at the amount of similarity. And if we go back right here, we can see that that would be in line with their sentiment analysis. Okay, so looking at their models, to classify the banks, they use convolutional neural networks. And below you can see their parameters. And then they also they used a support vector machine for weighted sentiment analysis. And they looked at text polarity, which I haven't heard of, and basically that took out the neutral statements. And they used a package in Python called TextBlob for that. And then also to look at the ROA and other financial variables, they used linear regression and support vector regression, and they showed their parameters for support vector regression. They did 10 runs with a shuffled train and test set at a 30% split. Here are their results, which is a pretty organized table. Here we can kind of see that the CNN plus GloVe ran the best in terms of F1 score. And then LSTM plus GloVe ran the second best. And then below we can see that linear regression severe or just really outperforms support vector regression. And also in leverage ROA and then leverage plus ROA. And then, so the findings that we had in here is kind of what I explained in the previous slide, that the CNN plus GloVe had the best performing F1 score overall. And then LSTM plus GloVe was better, although, LSTM plus GloVe was better in 40% similarity. Classification, we saw that the pre and post weight sentiment analysis had the biggest difference at 30% similarity. So yeah, you can see that here. The pre and post weight, we can see 87 and 91 at the 30% similarity. And then in regression, we saw that linear regression outperformed SVR insurmountably. What I learned during this this paper is that you can use the package TextBlob for word polarity, so to take out neutral statements. And then also that linear regression can outperform SVR regression by a large amount in regards to R squared. I didn't previously, when I've applied SVR in comparison to just linear regression, SVR usually has outperformed linear regression. And I'm not really sure why SVR performed so poorly in this space. And then I also learned about different ways to think about sentiment analysis, such as the neutrality and then the different thresholds you can set on similarity. Some criticism is that there's no real explanation on why SVR performed so poorly, and the paper lacked detail with the amount of tests that they ran. And there's also no visualizations given by the paper. And then there's also a strong assumption that CNN would outperform best in this instance. What we can apply to our project is looking further into performing regression on performance metrics, and then we can look into applying similar thresholds of the similarity thresholds that they presented, so 30% and 40%. Here's the source, and thank you for listening.